So now the system of mass is tied by the string. So from this figure, you need to, you are going to understand. So let's do a figure first. So now this is the system of masses tied by the string. So in a string, as we know, there is a tension force is going to be generated whenever any particular thing you attach, you tie, or you can say applied with the string system. Okay. So starting with the same thing, two body mass system, or you can say two bodies. Let us consider the case of a two body. Let us consider the case of a two bodies. Let us consider the case of two bodies of mass m1 and m2 connected by a thread and placed on a smooth horizontal surface. Okay. So what it is happening? They are connected with this string, and we apply a force in this particular direction, and they are placed on a smooth surface. Smooth surface means there is no frictional force is going to be, okay, because it is a smooth surface. So there is an assumption, obviously, even if you apply, even if you put any particular boxes, even a smoother surface, that is going to be a friction force, but still we assume that, showing in this figure. A force F is applied on the body of mass m2. Okay, clear enough. In forward direction, our aim is to consider the acceleration of the system and the tension T in the thread. The force acting separately on two bodies are also shown in the figure. Means what our aim is? Our aim is to find the tension force or different forces on this two mass system. Clear, everyone? So that is all about FBD, free body diagram. So first of all, from the system we separated these two masses. Clear. So on okay, and that is 2. On mass 2, we generally apply a force in this direction. Fair enough. So that is going to be accelerated in the right hand direction. But due to gravity, there is a m2, and due to the surface, there is a normal force n2. And the tension force due to this thread is going to be applied in this direction. Clear enough? But the tension force is going to be applied in this sense, in this side, and there is no force in this side, but due to the gravity or due to the mass itself, there is a mg force on m1 mg, and there is a normal force n1. And because it is a system and the whole acceleration is applied in this direction, so this box even having acceleration in the same direction, in this same direction. Here, so from the figure, tension T equals to m1a. Why so? To balance this particular tension force, there is a some force, and that particular force is F1, and F1 is nothing but m1. Clear? But on the second, on this only, there is a force F going to be applied in this side. There is a tension going to be applied in this side. So the force F2 on mass m2, the force F2 on mass m2 is total force minus tension force. Clear enough? Where tension force is m1a, and this particular force F2 is m2a. So that is, we write it down in these two equations. Going into the next page, adding 1 and 2 means adding 1 and 2, what we get, as you can see, 1 and 2 add equation. So you get the total force, which is F, and m1 plus m2. So this is your adding 1 and 2, we get total force F equals to m1 plus m2. That is quite obvious, but we need to prove that. So that is A acceleration is F, net acceleration is nothing but whatever the force you applied, m1 plus m2. Clear? Now if we want to find the tension force, so tension force T is nothing but m1a. Clear na? Tension force, we find this thing, so that is m1 F divided by m1 plus m2, and that we're going to find on the next page. Okay, that is for the two mass system. And if you want to find this m2a, so that is simply F minus tension. So F minus tension force is M2A, which is force on F2, is nothing but force minus tension. That is F we take common. Now, clear? We can take it out common now. I mean, if we can take it out common, F and tension force is M1 F divided by M1 plus M2. And directly from there you can get the right hand side, sorry, left hand side, even with this formulas also. So that is all the scenario when only two bodies are interacted with this thread system. In the same way we are going to find for 3, like in the previous case. Okay, so till now what we are doing, first we put two bodies side to side in contact with each other and apply a force from left hand side, from right hand side. We find the relation with them. Then we separated with the two bodies and apply, or you can say attach these two bodies with a thread. So we can find the tension force. And then we apply same rule for the 3 body system. Clear enough? Okay. So now this is again the important one. System of masses started by string. Now we take 3 bodies. In case of 3 bodies, the situation is shown in figure. Everything is remaining same. Just the simple scenario, we are going to do this FBD for 3 things. Instead of 2, we are going to do that now for 3 things. And one main thing, on each particular masses, the acceleration is going to be in the right hand direction. Why so? Because we apply net force only and only in right hand direction. That is this. So acceleration is going to be F total force divided by M1, M2, M3, following this particular scenario. Okay. If I apply next mass also, tension in T1 is M1A, that is M1 into F divided by M1, M2, M3, equation number 5. Now this M3A is force on third only, that is force minus tension 2. And what is tension 2? Then tension 2 is nothing total force minus M3A. So putting the value of A, we get this tension 2 even. Is this clear? Clear now? So tension 2 you can find not only and only because of this mass 2, but it is carrying the tension, or it is carrying the mass, this one also. You can see from here. Because if we put this whole thing, so we get automatically tension 2 is F, which is okay, F minus M3 A. A is here F, M1 plus M2 plus M3. Okay, and just doing the simple calculation, taking F common, we get M1 plus M2 into F divided by M1 plus M2, M1 plus M2 plus M3. And what it is? F divided by M1 plus M2 plus M3 is nothing but, it is, what it is? It is acceleration. So M1 plus M2, M1 plus M2 into A. That is, I got it. Is this clear? So we just apply one more mass, and we need to find, I mean we are trying to finding the tension T1, tension T2. Clear? Good. And this M1G, M2G, M3G, reaction force 1, reaction force 2, reaction force 3, simultaneously you can say normal force 1, normal force 2, normal force 3 are same. Because in vertical direction we are not applying force any till now. So they are balancing each other. We don't need to worry about it. Now this is very important, pulley system. So in general, so many cases, simply, first of all, if anyone is belong from the village area or their forefather or father, so he or she, I mean from you guys I'm talking, one of you guys may be seen that particular pulley system in a well. Okay, so in wells we have a pulley, and with the help of pulley we can pull the water from the bucket from the well itself. So what this particular pulley helps, this pulley helps to you can say pull the water easily, simple. But still in this particular pulley system there is force, whatever you force apply, and there is a force, tension force in the string, and there is a force mg, whatever the particular you can say mass you're going to pull it up. Clear na? And this particular pulley system in railway system is going to be very crucial nowadays, because in nowadays we have a electric engine always, or if the wires of electricity is going to be loose a little bit, so they are going to touch the roof of the electric train or electric railway engine, and they are going to blast. So to maintain the strength, or you can not strength, to maintain this particular tension, or you can say these wires straight enough, what we are doing in general, on the one hand, on this particular, each particular, after certain particular distance, we apply a pulley, and with the help of this particular pulley system, this is going to be attach a mass. Just a minute. Okay, so these wires are going to be straight in, and here the train is going to be running perfectly. That is the system. Clear? So that is why pulley and the system, this particular pulley system is going to be very crucial. Now this is just a simple case. What if I am applying this particular pulley on a tilted plane? We are going to see that. Okay, so that is the thing we are going to find it down, because it is not necessary the pull is going to be always horizontal. What if I want in this way? Clear now? What if I want in this way, tilted one? So we are going to follow, we are going to see the different cases there even. So the simple thing, a pulley, what is a pulley? A pulley is a simple machine that consists of a wheel with a grooved rim and a rope or a cable that runs along the groove, along this particular groove. This is the groove. Okay, this one. Along the groove, it is used to help lift or move heavy objects more easily by changing the direction of the force needed to lift the object. What is meaning of this? See, to lift this particular heavy object, we are not applying the only this force. We are applying this tension force. So with this tension force, this normal force is going to be subdivided. This normal force, which is of the equal to the mg of heavy loads, is going to be subdivided. One force, whatever we need to apply, and another force is taken care by the tension force of the rope. Clear? So that is why it is important. Okay. So free body diagram of pulley, case 1, and there are so many cases going to be. So focus here. Just next 20 minutes and then we are done. But 20 minutes you need to take care. Clear? Okay. So what is happening here in case 1? As you can see, this mass M2 is lesser than mass M1. Clear enough? And that is why this mass M1 is dragging downward side and mass M2 is lifting upward side. Clear enough? Clear enough? Okay. So in this particular string, there is a force. I mean, this particular tension force is equal to the normal force, and one tension force is going to be applied due to this wire, due to this thread. In a same sense, one tension force is going to be due to this thread and another in the opposition of this normal force, or you can say normal reaction force due to this M1G due to this M2G. Making FBD, free body diagram of both the things. M2G is going to be balanced with this acceleration, or M1G is going to be balanced with this tension. There is no acceleration till now. This is not moving at all. If case 1, if M1, M2, M, the tension force in the string is mg, acceleration A is 0. Why so? Because if both the masses are equal, so they are going to be balanced out. Clear na? In old days, the you can say weighting system is going to be some kind of this pulley system, and they hold like this, and when the mass of 2 kilogram and you can say the weight on the other side is going to be equal, so that in this way they can weighing the foods or vegetables and you can say wheat, rice and so and so. Right now we have a digital system. Okay, but maybe on you can say an older shopkeeper or fruit seller you can find it out. Clear? So that is same thing. Acceleration is going to be zero. Why it is going to be zero? Because if the masses are on the both hand side is going to be equal, so they are not going to move a little bit because now they are balancing each other. Mg. But reaction at the pulley R equals to 2 times of tension, because the reaction, the pulley, we are talking right now about pulley, not the tension in the wire. So reaction force in the pulley itself, whatever the you can say vegetable seller or a food seller is holding that particular, so that reaction force is double of this tension force, because this tension force is going in this direction and both the tension force is going in upper direction. So reaction at the pulley is R, which is 2 times of T, and tension force is nothing but mg, because m1 m2 are equal, strength or support or suspension. Is this clear? So from here what we can get, tension force is nothing but reaction force upon 2 or divided by 2 simply. Then moving ahead, case second, important one again. If m1 is going to be greater than m1 m2, means m1 here, as we can see in the original diagram, is going to be greater than m2. So m1 is going to be follow in this case, and when m1 is greater, so acceleration on m1 is downward side, even acceleration on m2 is upward side. Why? So very simple, where the tension force on this particular string for m1 is going to be in the upward direction and tension is going to be remain the same. For m1 greater than m2, mass m1 m1g minus t is going to be m1a. What we are doing basically, as we can see, the net force is traveling in this side. Clear? And m1g is going to be in this side, but there is a tension force in this side. So the net force on mass m1 is F1, that is m1a is nothing but this m1g, whatever the mass of this, minus tension force. Whatever the tension force is going to be applied, we need to subtract that, because tension force is going to be in upward direction. Clear? Okay. For mass m2, m2g equals to m2a. Why we not take care of tension here? Because whatever the tension apply in this, we subtracted already in this. The same tension force, because the string is same, the thread is same, right? So we are not considering here. And obviously m2 is going to be upward, so this m2g is taken care with this net force, which is taken, which is accelerating this mass into the upward direction. So F2 is m2g is m2a. Clear? Okay. Now to get A is m1g minus t, which is you can say from here tension force we get, first of all, not A, solving we get one thing is missing. Okay, that is not going to be m2a, that is going to be tension force, or you can say m2a also. Means whatever the tension force on this particular string on mass 2, that is going to be m2g. So if we put this t here, so we get A. Clear? And that is m1a is m1g minus tension, and tension force is m2g. Then A. Wait for a while. I need to check this thing. Okay, one thing is missing here. Huh. See, this equation needs to force on mass m2. Yeah, I got it. What is the wrong here? See, force on mass m2, one force is missing over there. This mass is going into the upward direction with force F2, right, which is M2A, because in this acceleration is moving upward and the tension force is moving upward also. Clear? So here what is happening, force on mass M2 is M2G is going to be balanced by tension force plus M2A. Clear? This is the scenario. Now, if I can do one thing, this is my equation second. From both the equation, I can take tension one side, tension force, to find acceleration. Okay. So what we can do from equation 1 and 2, from equation 1 or 2, tension force is M1G minus M1A, and from here tension force is M2G minus M2A. Clear? Clear na? Okay. If these are equal, so what we can do then, now this is, you can say 3 and 4, equation number 3 and 4, you can put it down. Now from equation 3 and 4, because in left hand side we have a tension on the both sides, so then M1G minus M1A equals to M2G minus M2A. Clear? Is this clear? Okay. Now M1, there is going to be one catch, M1 plus M2. Wait, tension. That is going to be minus of T. I mean, we need to solve in this way so we can get this relation. This relation is correct, but wait, I need to check this. Tension minus this. Case number 4, first, second, third. M2G tension. M2G and then tension T. Solving, we get acceleration is M2G. So A is D. No, this is not correct. See what we are going to do. This reaction or this force on mass M2, M2G and force F2, which is M2A, is going to be M2A and tension is going in the both direction. Okay, and then it is going to be tension force is going to be M2G minus A, and tension force is going to be, I am doing wrong here. Here it is going to be positive, because you can see tension and this, I mean, okay, wait, this M1G and force F1 in the same direction, na? Clear? And from here itself, it is not correct even. See what is happening here. F1, which is M1A or M1G, are in same direction. Clear? Is this clear? So tension force for mass 1 is going to be here. It is M1G. It is going to be positive. This equation M1G plus M1A is tension. Okay, now this is correct. Or M2G is tension plus M2A. So tension and this tension, now it is correct. So solving these two equations, okay, tension equals to this, we can get this acceleration. If we add both the equation, if we equate both the equation, so what you get? Equating these two equations, now M1G plus M1A equals to M2G minus M2A. This is going to be this side and this is going to be that side. Clear? So M1 plus M2 into A. The positive negative sign you need to take care, and then M2G or M2 minus M1. Yeah. So this is also correct. Now this acceleration is M2 minus M1. M2 minus M1 divided by M2 minus M1 divided by M2 plus M1 or M1 plus M2 G. Clear? So from here we get this relation. See. So from there you can get acceleration. Net acceleration on this particular system is M2 minus M1 divided by M1 plus M2 into G. Okay. So what is happening here? Just once, because the next thing is going to be a little bit more tricky, or you can say more. This in this pulley system, if mass M1 is greater than M2, so what is happening? Both the forces are applied, both the forces are in the same direction for M1. This F1 force or this M1G. And in that opposite there is a tension T. So we can write this. But for mass M2, M2G is in the downward direction, where tension force plus F2, which is M2A, is going to be in the upward direction. Now comparing tension with this equation 3 and 4, we can get this relation. Okay. So that is the main thing. Moving ahead, or free body diagram, this for T2, if M1, M2 is going to be the same thing, or tension T, okay, putting A, or you can say from any particular equation, when you put T, or you can say A in this equation, so you get this relation. T equals to 2M1 M2G divided by M1 plus M2A. In any particular equation, either in equation 1 or either in equation 2, then we put the value of acceleration, which is M2 minus M1 divided by M1 plus M2 into G in any of the equation related to this. In any of the relation from the previous page, so we can get this 2M1 M2 G divided by M1 plus M2. And we know that the reaction force on which? Reaction force on this particular pulley system is twice of tension. So that is 4M1 M2 G divided by M1 plus M2. And these two relations are very, very important. Is this clear? Is this clear with everyone? Anil or Kanishka or Satya or Murish, Mukeshwaram, Ashwin, Pranav or Bhuvana. Is this clear, beta? Or you slept? Bhuvana. Okay. So the next thing in the next few slides, we are going to do the focus in the same sense. Now case 3 for free body diagram. Now I'm not going to explain that much again. Just you need to follow the same case because we are running out of time, and I think I need to take your 5 minutes extra today. So for free body diagram of pulley system case 3, if I attach one more mass onto the M2. So for mass M1, T1 minus mg equals to M1A, M1. Okay. T1 minus mg equals to M1A. Fair enough. Tension T is M1A plus mg. Clear? Means tension in the upward direction and M1G plus M1A in the same direction. Okay. For mass M2, for this mass only, M2G plus tension 2 minus tension 1, M2G plus tension 2 minus tension 1 is equal to this M2A. For mass M3, M3G minus tension 2, because tension is applying in the upward direction, or this M3G is applying in the downward direction, and this, because of this heavy two masses, the net force on this M3 is downward direction. Solving these equations, first, second and third, you can get M1 plus M3 minus M1 divided by M1 plus M2 plus M3. Putting the value of A in equation 1 and third, the tension T1, T2 can be calculated. In any particular equation, when you put the value of acceleration A, you can get T1 or you can get T2. Clear? Alternative method, T1 equals to M1 G plus A. T1 is the effective weight of M1. T1 equals to M2 plus M3 G minus A. T1 is the effective weight of M2 plus M3. And T2 is the M3 G minus A, effective weight of M3. So equation 1, 2 and 3 gives us, when we equate all the three equations, so automatically we get the same thing, same scenario. So there are two methods given in this case number 3. You need to just recheck and follow the same sense. Clear? Good. From equation 1 and 4, we can find the acceleration, or you can say net pulling force divided by the total force. So better recheck this and check this once. Okay. If you feel anything that is not after solving every particular equation, so you can let me know in the next class. But you need to check this, because unless you are not doing by yourself, see, I can do so many times, still in explaining you guys, I took a lot of time, so you need to do that by yourself. Okay, very important stuff. Now this is case number 4, and that is important. So if I apply a pulley at the end of this, clear enough, and there is a tension T. So due to this, if it is M2 is going to be downward side, so there is a M2A, but M2G also is in this. So first case is free body diagram of a pulley system on this string system with the string system. So without friction, for mass M1, M1 is having only tension T, which is M1A, because it is sliding down towards this. So tension in this particular, or obviously we have a M1G also, but we are not taking care of this right now, because it is in the vertical direction. In horizontal direction, the tension force having M1 only. So this is your equation number 1. For mass M2, we have M2G and M2A, or you can say that M2A plus M2G is tension force. Why so? Because for this, the tension force in the upward direction, as you can see that the tension force in the upward direction, where this gravitational force and the accelerated force due to this M2 is going to be downward. So solving both of the equation, we can get A, which is M2G divided by M1 plus M2, and then we can get tension. So that is easy one. Clear? Just do this, equate both of the equation, so you can get acceleration, and when we get the acceleration, we can get the tension. Clear now? With the equation 1 or 2, or you can put this one also too. So then it is going to be this one. Okay, now if there is a friction also be there, so what is going to be changed then? B, friction. With friction, friction in between surface and block. So there is a mu mg, and okay, frictional force is going to be mu n. Mu n. N is going to be mg. Okay, frictional force. Frictional force. If it is moving frictional, so kinetic friction is going to be mu n. What is mu? Coefficient of friction. Clear? Where mu is, it is given coefficient of friction, for given surface. Clear, everyone? Clear na? So that is the frictional force. If we have a frictional force, so friction between surface and a block, so what we are going to find, what we are going to see for mass m1, tension minus mu n. N is m1g, because in the upward direction we have m1. This is normal force, and normal force is m1g. So tension minus mu m1 is going to be m1a. Is this clear? This is tension is going in this direction, frictional force is applying in this direction, and obviously it is sliding down towards this because acceleration is towards this, so the net force towards this. This is equation number 1. In the same sense, for mass m2, the same thing we are going to follow. M2 and tension is going to be in this direction, and the net acceleration is in this direction. So m2a equals to m2g minus tension. This is my second equation. Again, solving both of this, we get the acceleration m2 minus mu m1 divided by m1 plus m2 into g. And once we get this acceleration, we get the tension also. Clear? You don't need to do, you don't need to take tension until unless you are solving this by yourself. The moment you try to by heart, the moment you try to learn this thing, the tension in your head is going to be increased also. Clear? So don't take tension, just try to understand this, try to do again after this class within a day or two. Okay, case 5th, if I attach a capital mass with these small two masses. Now m1, m2, so just this one thing, the capital box is moving in this way, so tension T1 is in this way and tension T2 is in this way. Obviously, if m1 is larger than m2, so the net acceleration is going to be in this direction. Clear? Because this is heavy mass and that is greater than m2, so it is going to be upward and it is going to be downward. So m1 greater than m2. So in the same sense, then what we are following till now, m1g minus tension, I mean this m1g is going to be in this direction, tension going to be in the upper direction. So the net force on F1 is going to be m1a, and that is nothing but m1g minus tension T1. In the same way, tension going in the upper direction, net force F2 is going into the upper direction. So then tension T2 plus M2A is going to be this M2G, or you can write it down in the reverse direction. This M2A is nothing but tension T2 minus M2G, because both are in opposite direction. So this is my first equation, the same thing. This is my second equation, the same thing. Now MA. Okay, so as you can see, the net force on this particular thing is going to be in this direction, MA. So tension T1 is going in this direction, tension T2 is going to be, so tension T1 minus tension T2 is net force on MA. This is the third equation. Solving all the three equations 1, 2 and 3, we can get A, M1 minus M2 divided by m1 minus m2 into g divided by m1 plus m2 into capital M, and then tension T1 we can get, then tension T2 we can get. So tension T1 is m1g, or A is 2m2 plus m divided by into this, and then m2g 2m1 plus m capital M divided by m1 plus m2 plus capital M. Okay, so all these things I repeat once again, you need to check by yourself. This is look same. Check these calculations. Okay. Now this is the important case, free body diagram of a pulley system. So very, very important. Let me check how much is this still remaining. Pulley system is there. Free body diagram. Oh my god. Or should I do this? Okay, do one thing. But if I stop here, the questions attached with this one is easy and second is easy too. Or I should take 10 minutes. Okay, let's do this. Okay, so this is your free body diagram for pulley system. Now on a wedge we apply the pulley. So what is, we already done this thing, like there is a m1g sine theta, there is m2g in the groundward direction, and the normal force is m2g cos theta. What more complex is, a tension T is applied on this particular thing, where m1g is going to be in the downward direction. So obviously tension T is going to be in this direction. So mass suspended over a pulley from another on an inclined plane. So A without friction. This case is very easy, without friction. So without friction, for mass m1, m1g minus T tension is m1a. For mass m2, as you can see in the previous page, I also write it down. There is a tension T, but in the opposite direction, this m2g, this m2 sine theta. Okay, that is m2 sine theta. m2g sine theta is m2. So the net force on this is tension minus m2 g sine theta, or net force on this particular mass m1a is m1g minus tension T. Clear? So if you want this acceleration, so that is very easy. How? Add both the equation. Adding both the equation, A, that is m1 plus m2, that is tension going to be cancel out, m1g and minus of m2g sine theta, you can get the acceleration. Clear? m1 minus m2 sine theta, g taken common out, m1 plus m2. And once we get the acceleration, once we get this particular acceleration, we get the tension also. Clear? Good. In a same direction, in a same sense, not same direction, in a same sense, what we can see that with friction. So with friction, what is going to be just change? This mu n. Clear? Because there is one more force is going to be in this particular, that is frictional force. So for m1 that is going to be very easy, same thing, same sense. m1a is going to be net force on this particular is m1g minus tension force. Okay, first equation. N2, you can say normal force is m2g cos theta, and kinetic force mu n is mu m2g cos theta. Simply. For m2 is going to be the crucial thing. Here, the net force on m2 is m2a, tension minus mu m2g cos theta minus m2g sin theta. Again, this is your first equation, this is your second equation. We net this acceleration. add both the equation. Tension is going to be taken care of again because it is negative, it is positive, and again we get this acceleration and we get this tension also. Clear? Clear? Solve this. Again I am writing this. Solve this and check it out. And check. And I need your 5 to 10 minutes more today. Now this is the important thing. Now what is going to be, we just after slide by slide, after each particular slide, Kanishka thinks, sir, after each slide increase the complexity of a diagram, and then simple two things we are finding: net acceleration, okay, with the FBD. Once we find the net acceleration A, then putting in any particular equation, finding the tension T. Simple this thing we are following. Just just on each particular slide, the complexity is a little bit hard. That is the case scenario. Now case this 7th, mass M1 and M2 are connected by a string passing over a pulley. M1 is greater than M2. Okay, then for mass M1, okay, focus on M1 only. For mass M1, M1G alpha. Now this is alpha, this is beta. So M1G sine alpha minus T is going to be this. Okay. So this is your first equation. In the same sense, and that is the case for without friction, because we are not taking care of friction here. M2G is going to be in this direction. Downward following in this particular direction. So M2A is tension because M1 greater than M2. So the net tension is going to be in this opposite direction, minus M2G sine beta. And this particular net acceleration is in this direction. Just follow the direction of net acceleration, because net acceleration is in this direction. Why so? Because M1 is greater than M2. So that is going to slide downward, and that is going to slide upward. Clear enough? So if it is going to be slide downward, so this M1G sine alpha and M1 acceleration is in the same direction. So we need to write this equation. Again, adding first and 2, tension is going to be cancelled, and that is going to be the case. Simple thing. Okay. And again, we check, or you can say solve it and check it out. Clear? Now the next thing. For the last case, I think that is last. No. Oh my god. 8th na? हाँ बेटा, that is last. Just last case. For 8th case. From case 4A, we know that tension T equals to M1 M2 divided by M1 plus M2G. I mean, in this particular scenario, okay, that is very, very important. Very, very important. Why so? Because instead of simple string, we have a spring here. Okay. So from 4A case, we know that tension T in this kind of scenario, M1 M2 G divided by M1 M2, and tension in the spring, tension force in the spring, that is force, that is tension, that is Kx. Okay, there is a spring force Kx. In general, that is going to be the negative sign, but right now we are not considering the sign, so that is Kx. So X is the extension in the spring, that is Kx. This is tension by K, and that is this. So this simple thing you need to understand, because we find it down already. Tension in this particular system is going to be M1 M2 G divided by M1 plus M2. And if you want to know how we get it, I can tell you also. Here, tension and M1 force, the basic acceleration is going to be in downward side. So M1A is tension force only, because in this particular tension is going to be in this direction. Okay, just don't go into the depth of this, because that is need to take another 10-5 minutes. Okay, now this is your first question on this particular thing. Try to do that. What it is given over there, here all surfaces are assumed to be frictionless and pulley is assumed to be ideal. This pulley is ideal. The block A is projected towards the pulley. It is going to be in this side with an initial velocity u. Then select the incorrect option. Oh my goodness. Full JEE level wise. Okay, I can give you the hint, or I can teach you, because giving hint right now is not a sufficient. So what is happening here, when the string is taut against the both block and would travel the same distance, means if I'm giving us some initial velocity in this side, so basically what I'm doing, I'm you can say pulling this string towards downward side. Clear? Okay. Then when the string is taut against the block would travel the same distance. So ut, which is initial velocity, and t equals to half gt square. Okay. So that is half gt square. In free fall case, s, which is, you can see, in free fall case, which is s equals to u naught p, and at that particular peak point, initial velocity is going to be 0, so that is half gt square. Okay, so from here t equals to 2 mu naught upon g. In this time, a and b would be the travel distance of 2 mu square upon g along the wire. Change in the momentum of the same both and block. Oh my goodness. Okay, right now you don't understand this. We can discuss on chapter assessment. Okay, skip this question, right? Do this one, that is easy. And then you need to open and see that chapter assessment also. Okay, I can tell this one also. See, 3 blocks of mass 1, 3, 2 and 1 are placed side by side. Okay, on a smooth surface, a horizontal force which is 12 Newton is applied on a 3 kg. Find the net force on 2 kilogram of block. So all the blocks are moving with the same acceleration in horizontal direction. F is total force is 12 Newton, which is MA. That is 12 is 3 plus 2 plus A. I mean 3 plus 2 plus 1 plus A. So from here we can get A. Force at 2 kilogram is 2 into 2. Mass into acceleration. Is this clear? Only this particular thing, F2, that is M2 into A. Because there is no string attached, there is nothing. So this A is the correct answer. So what we are doing here, first of all finding A and then finding force S2. So many things we discuss in this class. I don't write it down. Newton's third law of motion, conservation of momentum, equilibrium particle, or common forces in mechanics or machines or contact force and so on.